today, we're going to look at something more than just a famous data set. We're actually unpacking the blueprint for an algorithm that could, quite literally, save lives and slash healthcare costs. So let's dive in and see exactly how this kind of blueprint comes together.
So here's the deal. Type 2 diabetes is a huge problem. And the real issue is that when it's caught late, the costs, both human and financial, just explode. The complications get way more severe, and treatment becomes a lot more intense. The stakes are just incredibly high for everyone involved.
And that brings us to the big question, right? The one that drives this entire project. How can we use data to get ahead of the curve? Is there a way to spot the risk of diabetes before it turns into a full-blown crisis?
Well, the answer lies in a big shift in strategy, moving from being reactive to being proactive. The goal isn't just about treating diabetes anymore, it's about flagging that risk as early as we possibly can.
You know, before anyone even thinks about writing a single line of code, you need a crystal clear objective. And this is it. It's not about building some cool algorithm, it's about a real-world outcome, cutting costs and preventing serious health problems by finding at-risk patients sooner. This right here, this is the why that guides every single decision from here on out.
So, what are we working with? What's our raw material for this whole plan? It's the Pima dataset. We've got about 768 patient records, 8 predictive features, things like glucose levels and BMI, and then our target, whether the person has diabetes or not. And you'll notice we've got missing values, a classic real-world data problem we're going to have to tackle. This takes us to what I think is the most critical part of any data science project, actually crafting the blueprint. This is what we call the business understanding phase, where we translate that big picture goal into a concrete plan of action.
See, the model isn't just spitting out a prediction into the void. It's built to answer a very specific question for a doctor or a nurse right there in the moment. When they see a patient, vitals, and lab results in hand, the real question is, what do we do next?
And this is just brilliant because it shows the real-world's impact. The algorithm score isn't just going to say high risk. No, it's going to be directly tied to one of these 4 concrete actions. This is how a prediction becomes a decision. It's how you turn a simple number into a clear path forward for the clinic.
Okay, so we've got a plan, we've got actions, but how do we actually know if it's working? I mean, really working? This is where we have to define what success even looks like. And it's a little more complicated than you might think. We need to make a really important distinction here between 2 kinds of success. Over on the left, you've got business success. That's the what. These are the outcomes that really matter to the hospital and the patient, right? Fewer ER visits, catching it early. Then on the right, you have analytic success. That's the how. These are the technical metrics that data scientists use to figure out if the model is any good.
And here's the absolute key. You have to connect the 2. They aren't separate things. For example, a high recall score, which just means we're catching a really high percentage of all the actual diabetic patients, that directly leads to fewer ER visits. You see? The technical metric is there to serve the business goal. That connection is everything.
Okay, but no plan is ever complete without thinking about what could go wrong. A truly great blueprint isn't just about the sunny days scenario. It's about planning for the real-world problems you're almost guaranteed to hit.
And yeah, there are plenty of them. First off, the data's messy. There's also a big risk that this particular data set from the Pima population won't perfectly match the local patients we're trying to help. Then there are the ethical lines. This has to be a tool to support doctors, not diagnose patients. And honestly, just getting a new tool to fit into a busy clinic's daily routine, that's a massive challenge all by itself. But maybe the biggest hurdle is this clinical trade-off. Think about it. If we tune our model to be super sensitive, to find every single possible diabetic, in other words, to maximize that recall score, we are, without a doubt, going to get more false alarms. That means more unnecessary tests, more anxiety for healthy people. Figuring out that balance, well, that's not a decision for a data scientist alone. That's a deep conversation you have to have with the medical experts. So, after all this planning and defining goals and thinking about risks, what does it all turn into? When we go from blueprint to action, what do the doctors and nurses on the ground actually get their hands on?
It's not some super complex piece of software. The final products are practical, easy-to-use tools. A simple one-page scorecard that basically says if the risk is X, then you do Y. A playbook for the staff with clear instructions, maybe even some scripts for talking to patients. And of course, a dashboard for the people in charge to track if the whole program is actually working and meeting its goals.
And let's be absolutely 100% clear about this. None of this replaces a doctor's judgment. Not even close. It's all about empowerment. It's about giving doctors a powerful new tool, one that's built on a solid, thoughtful blueprint to help them make faster, more confident, and better informed decisions for the people they're trying to help.
Which kind of leaves us with one last thought to chew on. We always get so fascinated by the cool, complex algorithms. But, as we've seen here, the algorithm is really just the final tool that gets built. Maybe the real work, the true genius that turns a bunch of data into something that can save a life, is all in the blueprint.